Good morning, dear students. Today we are going to determine the total hardness, permanent hardness, and temporary hardness of the given water sample. For this, I may take 10 ml of the water sample, 25 ml of the water sample, or 50 ml of the water sample. It depends upon you. So here I am using 25 ml pipette, and I will suck water sample 25 ml and I will transfer it into the conical flask. So take it up to the mark, and if you are doing accurately, so your results will be good enough as a standard. You know, the hardness of water cannot be determined without maintaining the pH. So this titration is done at pH 9 to 10. So for this I am adding 5 ml of the buffer solution. This buffer solution is made from the ammonium chloride and liquid ammonia. So for this we can take, for the preparation of buffer solution, we take 71 gram of ammonium chloride and we dissolve in 500 ml of ammonia. So this is the perfect buffer solution. Now you see I have did buffer and the pH is now 9 to 10. Now I will add, this is the indicator, this is called the Erythrochromic black tea, we also call it EBT. As I will add 2 drops of EBT, so I will get a wine color. This is called wine color. Why it is developed? Because the EBT combined with the calcium and magnesium ions and produce this wine color. Now this will be titrated with the N by 50 EDTA solution, which I have filled in the burette. Here is the burette. You see, fill the burette up to the mark 0 to 50. So this capacity is 50 ml. Now I am adding EDTA drop by drop and observe the color change. You see, don't be in a hurry to add more drops. Drop one by one, drop by drop, drop by drop. So you will observe color change. You see, do it nicely. Do it nicely with continuous shaking. So you will find the change in color. So it will change from wine to blue color. See it? Take it very seriously. And once you are doing your practical, be very attentive in observing the color change. You see it slightly changing and it has changed. You see, now it has changed blue color from wine to blue. So this is the end point for this. This is the end point for this. So I will make a table and I will record the reading from 0 to the first. My first reading is 7.5. So I will record here. The reading starting from 0 to 7.5. It has been consumed. So I will take 2 more readings, and there must be 2 readings coinciding each other. If I am taking here, or if second reading, I am going to do it 15. So the actual volume consumed will be 75 ml and again 75 ml. When 2 readings are same, this is called concordant reading. And I will do the calculation for the total hardness of the water. So now I am showing you the calculation. You see, calculation can be done by using the N1 V1 formula. N1 V1 is equal to N2 V2. Here N1 V1 is the water is the water, and this is the N by 50 EDTA. So now here I am taking 25 ml of the solution, so N1 into 25 is equal to 1 by 50 into the V2, whatever I have taken from the reading of the burette, that is 7.5. So by putting the 7.5 I will calculate N1. N1 is equal to 1 by 50 into 7.5 upon 25. This is the normality of the water. Now you know the hardness is expressed, hardness is expressed in equivalent of calcium carbonate. So for knowing the concentration, H is equal to Ne, where N is the normality of the water and E is the equivalent weight of the calcium carbonate. So here by multiplying normality with the calcium 50, we will get the result of hardness in gram per liter. So our result will be in gram per liter, but we can change it into milligram by multiplying by 1000. So once we multiply with 1000, so our result will be expressed as milligram per liter. And you know, I have told you already that ppm and milligram per liter are same. There is no change. You can use ppm or milligram per liter. So I can write ppm or milligram per liter. So this is the total hardness, and by calculation I got 215 milligram per liter. After doing this, I will be doing permanent hardness. You know, to determine the permanent hardness, I will take the same water sample and I will keep it for boiling for an hour. You know, the temporary hardness exists in water due to the presence of bicarbonates, and bicarbonates are unstable. When they are heated, they are precipitated as calcium carbonate and magnesium carbonate. So after boiling the water for an hour, the bicarbonate will settle down, the water is filtered, and after filtration, I will take the water sample again. You see, the permanent hardness of water exists due to the presence of calcium chloride, calcium sulfate, magnesium chloride and magnesium sulfate. Is it clear? Now, after boiling, I will take the same volume of water, that is 25 ml, by sucking with the pipette. Do it nicely and see the mark. Transfer in the conical flask nicely, and the last drop should be in the conical flask. Now again, as you know, the hardness can only be determined at pH 9 to 10. So I will add buffer solution. 5 ml of the buffer solution. Because without adding buffer solution, I cannot get the color change. You see, I am taking 5 ml and added. Now I will put 1 or 2 drops of the Ariochrome black tea. You see, well, I am adding 1 or 2 drops. So you will see wine color. This is called wine color. And again, you will add EDTA solution drop by drop. So you can mark again up to 0. You can mark up to 0 and add drop by drop, drop by drop. So this reading will be less. This reading will be less than the first reading, because in this reading bicarbonates have been removed. So drop by drop, and you will find a color change, sharp color change from the wine color to the blue color. You see it is appearing. You see the color is changing very fast. The color is changing very fast and it has changed. You see this is the blue color. This is the end point. Again I will repeat the titration twice or thrice unless I get the same reading. So this time I am getting 6.5 ml of the EDTA solution consumed for the permanent hardness, and I will go for the calculation in the same manner. And after calculation, if I am getting the permanent hardness is equal to 180 milligram per liter. So this way, first time I got total hardness, second time I got permanent hardness. So what is the temporary hardness? Total hardness minus permanent hardness, you will get the temporary hardness. So this is very important and very commercial. You should know about the determination of hardness. Okay, thank you very much. तुम पागल